TCM, or temperature controlled molding, is a new process. And when I say a new process, you probably would think that it is not new. We've done temperature control and molds for a long time. What's different about TCM is the way we control the mold surface heat and do it instantly. It's been a long time in development, and it was very challenging to have a mold surface that really maintains whatever you dictate in terms of temperature up or down, and also in terms of temperature gradients, whether it's a ramp rate with dwell or whether it's descent. And of course, a lot of that depends on whether you have exotherm reactions during that process. What TCM does is it controls the exotherm instantly, and it maintains the profile that you really want to see regardless of the thickness of the laminate. We do thick laminates, and we say thick laminates, then high fiber volume fraction laminates up to 6-7 inches. We can do that. Is that necessary? In most cases not, but in some cases it's the only way to build a unitary structural part. Large girders, big caps, things like that. And if you have for instance, a very complex laminate, say one of the larger wind blades. A large wind blade is fascinating from a technical point of view, but it's very challenging because you have so many variables in the laminate. And most of the technology that is being used right now in wind blades is resistive heating. So you basically bump up the temperature slightly, get some reaction going, bump it up some more, and that way you come eventually to complete cure.
In conventional resin chemistry, what we tend to do is to use inhibitors, and these are typically hydroquinone type of technologies, phenolic-based type of chemistries. The negative of doing this is that when we're talking about a free radical polymerization, once these inhibitors go and align themselves with the free radical and capturing them, they're lost into the system. So they're forever gone. With the block builder technology, the real advantage that we see on it is they act like an inhibitor at ambient temperatures, but have the ability to, once they're exposed to heat, and at whatever that activation temperature is, and typically what we see is about 140 to 150 degrees F, is we see that the free radical is released and then is allowed to do its thing in terms of causing the cross-linking of the polyester or vinyl ester chemistry. That's the real big advantage, is that it's not lost, it is actually just captured and contained. Conversely, if the temperature drops down below that temperature, that activation temperature, it'll go back and capture these free radicals. So we have the ability to turn on and turn off the chemistry. Predominantly we want to turn it on, but we want to be able to control when that gets turned down. And that's the big difference between standard room temperature inhibitor systems and the block builder technology.